19th November 2024, the air quality index of Delhi exceeded 500, which was considered as severe by Central Pollution Control Board. The schools were closed, the traffic movements were restricted, the construction activities were stopped, and even public health warnings were issued by the authorities. But how was its severity determined? How do we actually measure the pollution in real time? And how do we know when it's dangerous? The answer lies in environmental monitoring. We use network of monitoring stations equipped with instrument that can track the pollutants like PM10, PM2.5, sulfur dioxide, nitrogen dioxide, ozone, and carbon monoxide. And it is analyzed through regulatory standards like National Ambient Air Quality Standard, and it is converted to Air Quality Index through some standard procedures. Welcome to the course Environmental Monitoring and Instrumentation. I am Dr. Prasenjit and I will guide you through this 12-week journey. The credit of this course is 4 and it is designed for the postgraduate students of environmental science, engineering, art sciences, researchers, environmental consultants, professionals in regulatory bodies, competitive exam aspirants, etc. In this course, we will discuss the types and classifications of environmental monitoring based on the media being assessed like air, water, soil, and biological, using either continuous or periodic methods for detecting pollution level, ecosystem changes, or compliance with regulations. How the environmental instruments works, from basic sensors to the advanced devices, by detecting physical, chemical, or biological signals such as temperature, gas concentration, or particulates, and convert them into measurable data using principles like electrochemistry, optics, and mass sensing. Frameworks for monitoring air and water quality, remote sensing and GIS using satellite or aerial imagery to detect environmental patterns over large areas, and spatial data for mapping, analyzing, and visualizing the pollution sources and the ecological changes. Meteorological monitoring including ambient temperature, humidity, wind speed, and pressure using ground-based sensors or weather stations. Quality assurance and data integrity, and national and international policy frameworks including NACs, BIS norms, and other international standards. We will also learn how monitoring data is used in environmental impact assessment and how it connects to global initiatives such as Sustainable Development Goals, especially goal number 3 on good health and well-being, 6 on clean water and sanitation, 11 on sustainable cities and communities, 13 on climate action, 14 on life below water, and 15 on life on land. After completing this course, the learners will be able to explain the principles and objectives of environmental monitoring and pollution assessment, design and implement sampling strategies for air, water, and soil environments, assess industrial emissions and pollution control measures using standard protocols, operate and interpret and critically evaluate monitoring data, apply quality assurance, quality control techniques, and generate environmental reports aligned with regulatory guidelines. Integrate remote sensing and GIS tools in large-scale environmental monitoring system, analyze and interpret real-world case studies to understand practical challenges, regulatory compliances issues, and the innovative solutions in environmental monitoring. The assessment model is quite simple. Internal assessment holds 30% weightage. Total 12 assignments from the delivered lectures will be there, out of which 8 of the best scored assignment will be considered for the evaluation. And the end-term proctored examination will hold 70% weightage, which will be a proctored online test. Thank you for your interest in this course. We look forward for your registration and active participation as we explore the science of monitoring the environment around us.